Welcome back to the second part of our data union creation process walkthrough. In the previous video we deployed our data union contract to the Ethereum mainnet, and in this video we'll be integrating that contract into our rock, paper, scissors app. We can see under the product section in the core app our data union progressed from the draft state to the deployed state when the transaction was mined. This means we're ready to capture some new details of our data union for our app integration. We'll be needing the Ethereum address of the newly deployed contract, the stream ID from the stream we created, which we call player moves, and the shared secret of the data union, which we'll generate shortly. So the first thing we'll do is we'll click on this product tile. There's a new section enabled called shared secrets. I'll click add shared secret. I will give this any name, click add. In the meatball menu, I will copy this and paste it into my Notepad application because we will need it shortly. Save and exit. Next is the contract address. I'll get that from the product tiles meatball menu. Copy ETH address, paste this in, and the stream ID can be taken from the stream section. And again, the meatball menu is convenient. I will paste that in. Great, so we have those three items. So let's introduce our app. It's very simple. It's a simple select box, rock, paper, or scissors, and when I press play, it will run this JavaScript code which will pit me against the computer, a randomly generated rock, paper, or scissors, and some comparison logic to determine who won. HTML on the right, JavaScript on the left. So very straightforward. And as we discussed, we'll be pushing my selection to the data union. So I'm going to be relying quite heavily on this Streamr client, and you can find that on NPM or GitHub. And I'll be using this unpkg to basically reach for the version that I want. I'm using the web version, and you can use a different version, but make sure it's at least 4.1, please. And yeah, you can locally host that or however you want to do it. Great, so let's go into the client documentation, and underneath authentication options is where we're going to start. There's a utility function called generate Ethereum account, which will generate our player's wallet. And I think that's a good place to start. So let's call this player wallet. And let's console log what player wallet is. Back to the app, refresh the page, and you can see that it returned with an object, address, and private key, which is an Ethereum account essentially. Now with that information, what we can do is, using this next snippet of code underneath the authentication options, we can create an authenticated entity on the Streamr network. So we can call this Streamr. Streamr equals new Streamr client. And the authentication choice is private key, and the private key is what we just generated. So it's the player wallet dot private key. Now I can console log the result for a sanity check. Paste that in, refresh, and here we go. So now we have all the endpoints that we need, and we are an authenticated citizen on the Streamr network. Great. So the next thing I will do is make some space, and going back to my notepad, I'll copy these in and I'll make global variables of these three items. I'll call this shared secret, which is a string. Contract address, maybe du contract. And stream ID, which we will creatively call stream ID. Great. So with these 3 items in, we have everything that we need. I'll give it another save. And I think the next thing we should do is join the data union. So if we go back into the client documentation, scroll down, here we go. So we have the data union's API. So I want this member function join data union. So I will copy and paste this in underneath the code that we added. Now it's going to be streamer.join data union. So this is kind of me. This is the player. And we're going to join the data union, and we need 2 parameters, the contract address and the shared secret, which we have. So let me paste in these parameters. And because joining is a promise-based API, we can say .then should return some member details, for example, and then we can finish the arrow function and console log what we get. Okay, so fingers crossed that should work. I'll refresh the page. We create the wallet. Here is the Streamr client, and we have a 3rd entry, which is the return of our join, and it is accepted. So we are now into the data union, and so we should push some data to it. So we can do that by creating a new function. We'll call this push data to stream, and it should have user choice as its input, and we will create a data point, which will be an object with the key move and the value user choice. You can refer back to the documentation here, but I remember it's streamer.publish, and I'll need the stream ID and the data that I'll be sending to the stream. And that's a classic publish. So lastly, I need to call that function, and I should call it at the end of the play function. I've already, with some basic JavaScript, extracted the value of this select box, called it user choice. So all I need to do now is call the function at the end. With any luck, if I refresh the page, make a selection and press play, it should have worked. So if I go into the core app, I click on player moves, our stream. If I go into the live preview, it in fact did work. So we are now pushing data into the data union, or into the stream that lives in the data union. And you can see that update in real time. Great. So next thing I think we should do is we should populate this data balance stats. Now, basically the user has fulfilled their side of the bargain. They're pushing data, and now they expect to be compensated for that data. So let's go back to our documentation, and underneath query functions we'll find this get member stats, which sounds like what we want. Go back into our code, and inside this join data union, then I will add in this streamer get member stats. Now I'm putting it here because we do want to be sure that we're in the data union before we request the stats. This is a demonstration. Obviously we'd only have one persistent player wallet, but every refresh we're creating a new data wallet, so we just need to make sure that we've joined the data union before we query the member address for the statistics of their account. So again, we need the contract address and we need their member address. So we have the contract address, and for the member address, we're going to use player wallet dot address. And again, this is a promise, so .then we can say stats console log what that is. And we should probably put that on the page as well. So perhaps we can write something like document.get element by ID, and then this data balance here. Data balance in HTML equals stats, and I already know the schema of the return, but I will show you in a moment. We're after this earnings part. So I've saved, go back into the app, wait for it to join, and here we are. Here is the statistics, and this is, we wanted the earnings of this object that was returned. It is 0 because we just joined and nobody's bought the product, so it's displayed accurately as 0. But let's make that non-zero. So we need to go into the core app and go back to products, and now we're going to publish our product onto the marketplace so that someone can come along and buy our data and remunerate our user. So I went back into the product section, clicked on the product tile, and now in the top right I can click continue, and I want to publish the product. Click publish, it'll come up with a new MetaMask notification. It's a mainnet transaction, and I will confirm this. So this will take another few moments, and so I will pause here and we'll come back to our marketplace listing. Okay, so the transaction was mined and we went from the deployed state to the published state. So now the product is live. I can go to the marketplace, do a search. There's 2 of them because I've been practicing, but everything worked well. This is the product page that we created earlier. We see we have active members. This is the stream that we created, and it's ready to purchase. So I'll click purchase. I'll choose Ethereum because I have some Ethereum in my wallet. I'll choose the access period of 1 day, and this is actually using Uniswap behind the scenes. I'll click next and pay now. So another mainnet transaction ahead. I'll click confirm, and in a few moments it'll be ready. Okay, so now we are a data buyer. If I scroll down and I click on our stream, view live data, we can see that we have access to all the users' data, which is exactly what we want. So if we go back into our app, we still have an existing user, an existing player details that we can use, and we should be able to plug them in. We can hard code them in and make sure that the data balance has gone up, and provide a means for them to withdraw their funds. So perhaps I can put this here, and we can call address existing address and existing private key. These equals, and so we want to use the existing address when we call up the stats, and the existing private key when we authenticate. Okay, now with any luck that should work. I'll just duplicate the page, and we have a data balance coming through. Great, it's just in the wrong format though, so we're going to use a library called ethers, and we're going to serve that through this UNPKG service again, just like we did with the Streamr client. So when you paste it in, it looks something like this. And what we'll do, we'll make this a little bigger, and we need to apply this to the stats.earnings. Now from memory, it is ethers.utils.format ether wrapped around that way number. If I refresh, okay, that looks good. So we have 0.67 data coins that have been earned by the user. It's their potential earnings, and now we just need to, our final task is to provide a means for them to withdraw their funds. The funds currently live in the data union contract, the smart contract. So I can paste in a little bit of HTML. It's just a withdraw button that calls a withdraw function. Withdraw. And inside that, I will call streamer.withdraw to contract. And so that's all I'll need to do. When I click this withdraw funds, the account will need some Ethernet, and this will withdraw 0.67 data coins from the data union contract into the user's personal wallet. And then we are done. So to recap, because we've covered a lot here, we created a data union contract on Ethereum, we integrated it into a simple app, we enabled the user to push data to the union, we published the data union on the marketplace, then we bought a subscription to that product, then we were able to show how much the user earned by selling their data, and provided a means for them to withdraw. So thank you so much for watching. I hope it's been informative. Please reach out on the developer forums if you'd like to learn more. Okay, cheers.